edges made up of transactions and other edges that recursively define themselves. An observation edge of an observation edge would become a depth level 2 node inside this type of a topology you can see. So looking at this kind of dendrite structure, you can see the outer nodes are going to be something like just a validator witness node, and something all the way on the inside, something very deep, is going to encapsulate a view that has the entire perspective of the whole network. So if you take a look at the center of the dendrite on the top, the center has a view of everything around it, but from the outside's perspective, it just has a view of what's local to it, and it also has an understanding of the total network, but just from a few steps behind. That's all that's necessary. That's really all that's necessary in order to apply some kind of an efficient validation. And that's sort of how we're able to have some of those, some optimizations. So yeah, this is kind of, this is what is required for us to actually build a data model, data structure that will allow for that scale-free network to just come out. Cool. So I have a little bit of a breakdown. This is going to be something I'm going to talk about in my demo, but basically the way in which our data is processed could be characterized as like asynchronous. Basically, we have a pipeline, a validation pipeline, where data goes through and it is handled by some asynchronous process that doesn't necessarily rely on somebody else. So in that sense, you can see sort of as we're scaling down this axis, I might have one process on a depth level 1. I might have a process on depth level 2 that's reliant on depth level 1. All of those processes can actually happen at the same time. So that path, if you were to follow the red line from the top there all the way down to the bottom, all of those different components that need to happen all happen on their own cadence, basically. We don't necessarily need to wait for an entire network to synchronize in order to have our network display the effect or to update itself. And as you can see at the bottom, this is basically a DHT. I mean, if you look at BitTorrent or some of the things we're doing to build those types of systems, just sort of a rehashing of that. So yeah, essentially this whole thing is a reactive execution graph. A future or some type of a process that is managing operations can then call off other processes, and they will self-manage themselves, returning the final result that you actually need. So from the perspective of actual execution, everything